what we're starting today is bringing all of this together, bringing everything we've done together with solving. Now, we're going to spend pretty much this entire week solving these higher degree polynomial functions. That's what we're going to be doing, because that's what we've been trying to get towards. With everything we've been doing, with our division, our factoring, all of this here has been leading up to this here, has been leading up to this, solving these equations here. So, now there's several ways that we can solve these, the first of which is factoring. We went over factoring when we did quadratics in the last chapter. We went over factoring again last week. The second method is going to be graphing. Quadratic formula and completing the square. These are kind of the main four ways that we know how to solve these polynomial functions. And number 3 and 4, these two here, work for quadratics, work for quadratic functions. Is it possible to use them for higher degree polynomial functions? Yes. But I would refrain from doing it because the overall process in which it takes to do them gets a little bit complicated and a little bit hairy very, very fast. So I would use these once I get it into a quadratic, or if I'm trying to solve for a quadratic, I'll use the quadratic formula or completing the square. I'd actually use the quadratic formula first. But these are our four main ways we know how to solve these higher degree polynomial functions. Now, the first few that we're going to look at, we're going to solve these by factoring, using the methods we learned last week to factor these and solve. So when I look at this here, so let's look at this first one here. 2x cubed minus 12x squared plus 18x. Is there a greatest common factor between all three terms? Well, there's an x. Is there anything else? There's also a 2, because 2, negative 12, and 24 all have a greatest common factor of 2. They all have a greatest common factor of 2. So the greatest common factor between these three terms here is 2x. And we can factor it out of each one. Now, if we factor 2x out of 2x cubed, I'm left with x squared. If I factor 2x out of negative 12x, well, 2 out of 12 will leave me with negative 6. X out of x squared would be x. 2x factored out of 18 would be plus 9 equals 0. Any questions on how we factored this out, our first step in this here? Okay. Well, now I can see that I have this quadratic here, x squared minus 6x plus 9. And we can factor that. We can see if we can factor that. Because it is a quadratic, we can do our two sets of parentheses with 3 spaces, because this is a quadratic, it's a degree 2. So we can factor it this way. Now the next step would be checking the signs. Since our constant term of the 9 is positive, the signs are the same and they match the sign of the middle term. And our middle term for this one here is negative. So I would have a negative and a negative. Our next step would be the factors of the first and third term. Well, the first factors of x squared would be x and x. So the factors of 9. 1 and 9 and 3 and 3. Which one do we want to use? I would use 3 and 3. And we can check this here. X times negative 3 would be negative 3x. Negative 3 times x would be negative 3x, which would give us negative 6x, which we wanted. So these here are factored. Yes? So we have x times 2x times x minus 3 times x minus 3 equals 0. Well, our zero product property says that whenever I have more than 2 or more things multiplied together and they equal 0, one of them has to be 0. So what that means for us is that I can set each one of these equal to 0, because the zero product property is telling me that one of these has to be 0 in order for this equation that we have, this 2x times x minus 3 times x minus 3 equals 0, for that equation to be true, one of these three has to be equal to 0. Because if one of these three statements, 2x equals 0, x minus 3 is equal to 0, or x minus 3 is equal to 0, if one of these is true, then our equation's true. Then the one above it is true. So let's look at this first one here, 2x equals 0. Well, how can I solve this for the value of x? Well, I can divide both sides by 2. Well, 2x divided by 2 would simplify to just x. 2 divided by 2 would be 1. 0 divided by 2 is what? 0. There's one of our solutions. How about x minus 3? Let's solve that one for x. We would add 3 to both sides, because negative 3 plus 3 would cancel, leaving me with x is equal to 3. And lastly, x minus 3 equals 0. We would add 3 to both sides, and we get x is equal to 3. And we're done. So we're solving these here. We're trying to find the values of x that will make the function equal 0. We found 3 answers, or 2 unique answers, because 3 showed up how many times? Twice. So in this here, for big ideas math, if we were putting this in, we could say x is equal to 0 and x is equal to 3. I don't have to put it twice, unless it asks for it. But 0 and 3 are our 2 solutions. These are the 2 values of x that will make this function equal 0. When x is 0 and x is equal to 3, it's crossing the x-axis. That's where the x-intercept is at. It is also our solutions, our rational solutions. These are the values we're looking for when solving these polynomial functions, these higher degree polynomial functions. Questions on this here? Any questions on this here? Let's look at the next one. We want to solve this one here. We want to solve 5x cubed minus 40x squared plus 80x equals 0. So again, we're solving these by factoring. We're going to solve these first few by factoring. Now, if I look at this here, is there a greatest common factor between all 3 terms? 5x. Because 5 will go into 5, 40, and 80, because it's a common term in all 3. And then we also have a term x in all 3 spots. 5 factored out of 5 is 1. X factored out of x cubed will leave me with x squared. 5 factored out of negative 40 will leave me with negative 8. X out of x squared leaves me with x plus 80 factor. If I factor 5 out of 80, or do 80 divided by 5, I'm left with 16 is equal to 0. Any questions on any of this here so far? Any questions on anything we've done so far? So if I want to solve, because we do have a quadratic there, yes? So I can factor it, yes? Do we have any other ways to solve for quadratics besides factoring? we could use the quadratic formula. And we'll do that here in a minute, because we'll factor this, and I'll use the quadratic formula to kind of show you we can get answers from it. Now, when we look at this here, if I'm factoring, the constant term is positive, so the signs are the same and they match the sign of the middle term. So they both be negative. Well, factors of x squared are just x and factors of 16. 1 and 16. 2 and 8. 3 doesn't work, but we have 4 and, which one do we want to use? 4 and 4. And if we do check it, it ends up coming out that the middle term would be negative 8. These are the factors. Any questions on how we got to this point here? Any questions on how we got to this point here? Now, because I have three things being multiplied together that equals 0, I know that I can set each one of these equal to 0, because again, when we're solving, I'm trying to find out what value of x is going to make the function equal what? 0. I want to find out what value of x will make this equation equal 0. So we have it set equal to 0. We factored down to these three here being multiplied together, and any two things or three things being multiplied together that equals 0 means that one of them has to be 0. And now we can solve each one of these here. Well, 5x equals 0. I would divide both sides by 5 to get x by itself. And it tells me what? X is equal to 0. What would we do for x plus 4 equals 0? We would add 4 to both sides. And I'd get x is equal to 4. And lastly, over here, we would again add 4 to both sides and get x is equal to 4. We're doing the note sheets a little bit out of order. I want to look at number 2 first before we deal with example 2. So it's at the top of the second page, or yeah, it's way back there, back of the second page. Did y'all find this here where it says 2 dot 2x to the 5th plus 24x equals 14x cubed? Did y'all find this on the note sheet? Yep. Right here. Robbie? Yep. So I want to look at this one here first. Now again, when we're solving any of these here, when we were solving quadratics, the one thing we needed is that we needed the equation equal to what? 0. We need these equal to 0. So if I'm going to solve 2x to the 5th plus 24x equals 14x cubed, I need this equation equal to 0. So the first thing I'm going to do is subtract 14x cubed from both sides. Now 14x cubed and 14x cubed, these here are going to cancel out. Now looking on this side over here, 2x to the 5th and 24x and negative 14 are subtracting 14x cubed. None of these are like terms because they don't have a variable with the same power. So nothing will combine. So we end up just getting 2x to the 5th minus 14x cubed plus 24x. Now, whenever you move variables from one side to the other in these higher degree polynomial functions, write them in standard form. So you want to write them in order from greatest power to least power. But we're wanting to look at this here. We're wanting to solve this equation. We're wanting to solve this here. So we're trying to find the value of x that would make this function equal 0 on both sides. Now we move the 14x cubed over by subtracting it from both sides so that we get everything on the same side so that we're able to solve this here. And we look at this here. Once we get everything on the same side, we want to see, is there a greatest common factor? Is there something in common in all three terms? And when I look across this here, well, there is a 2 that will go into all three, and then x. 2x will go into all three of these terms here. This 2 will go into 2, 2 will go into negative 14, and 2 will go into 24. X will go into x to the 5th, x cubed, and x. Now, if we factor 2x out of 2x to the 5th, we get not 2, but it would just be x to the 4th. Because we can take 1x out of x to the 5th. And 2 divided by 2 would give us 1. Now, 2x out of negative 14x cubed, x squared. And 2x out of 24x, well, 24 divided by 2 will give us 12. And that's it. So we're left with this here, x to the 4th minus 7x squared plus 12. So do we know a way to factor this here? Well, we haven't done too much with fourth degree polynomial functions like this here. Now, is this factorable? Yes. There's ways that we can go about factoring. One of them is called u substitution, where we set u to a certain value and plug it back in to help us solve this. But there's another way we can do it. Now, one of the things I know is that these two here are being multiplied together. So because of the zero product property, I can split these apart. Now, 2x equals 0. Well, this one here is not bad because we can divide both sides by 2 and get x is equal to 0. So that's not bad. But the x to the 4th minus 7x squared plus 12, that one's a little challenging, yes? So I want you to grab your graphing calculators, because that's what we're going to use them for. We're going to use them here. So what I want you to do is hit on the graphing calculator y equals. And let's type that in. So we'd have x to the 4th minus 7x squared plus 12. So x, you'd use the little caret key to do the exponents. 4, you need the cursor over so you're not still in the exponent. Minus 7x, and then there's the squared. Because you can either use the caret key 2 or the little x squared button, plus 12. And when you type it in, it should look something like this here. Or it should look exactly like this here. So you need... x squared. And once you get finished typing that in, hit graph. Anybody still needing to get this typed in? Yes, we got it? Now, again, we're looking for what values of x is going to make this 0? Where it crosses the x-axis, yes? Now, does this cross the x-axis anywhere? No, but it comes down and intersects it or kind of touches it right there. Goes second graph. So this gives us a table. And we're trying to find, so second graph will give us the table. Now, what we're looking for is what values of x are going to make y equal to 0. Well, -2 and 2 give us values of 0, yes? So those are the other two answers. Those would be the other two answers. Now, what it works out, and we'll get into this a little bit more later, is that anytime the function, the graph, touches the x-axis but does not cross it, it has an even number of zeros. It has an even number of zeros. So what it's really saying is that these 2 points here, -2 and 2, we have 2 values at each one. There's 2 -2's and there's 2 +2's. So by graphing this, really what we're saying, when I graph this here, we were able to see that x is equal to 2 and x is equal to -2. So graphing still works on these higher degree polynomial functions. We're still able to graph these and it tell us what the values of x are. And here it worked out to be 2 and -2. Any questions on this here? Any questions on any of these here? Okay. Let's go back to this here. So let's go back to example 2a. So this should be the back of the first page. Or actually, I think we're on the same page, aren't we? Okay. Now, we look at this here. It says find the zeros of this and then sketch the graph. Well, no, let's actually sketch the graph and then see if we can find the zeros. Now, whenever we want to sketch the graph, we want everything to be on the same side of the equal sign. Is everything on the same side? Yeah. There's -2x to the fourth plus 16x squared minus 32x. F of x is the same thing as what? Y. And again, when we're solving these here, trying to find the solutions or find the zeros, we're trying to find out what? What value of x is going to make the function equal 0. So what we can do is we can take this here and plug it in to our graphing calculator. So we have -2 x to the fourth plus 16x squared minus 32. And you want to type that into the first line of your graphing calculator. And once you get that typed in, hit graph. And that's what you also need to make sure doesn't happen. Plus 16x to the squared minus 24, 32. And once you finish getting this typed in, hit graph. Once you finish getting this type in, hit graph. It doesn't cross it, but it comes close twice, doesn't it? Let's go second table, -2 and 2. And that's it. So if it's whole number values, this graphing calculator will give them to you. So the answers for this here are -2 and 2. X is equal to -2. And x is equal to 2. On the homework assignment, it's going to ask you to do this and identify the correct graph. So you'll need to graph these and pick out which one of the graphs it is. Now, picking out the correct graph, well, it's just going to be this here. Because we can use the graphing calculator to tell us which one of the graphs it is and then pick the corresponding one. Any questions on this here? So our answers are 2 and -2. Find the zeros for this one here and sketch the graph. So again, we're going to use the graphing calculator to graph this. So we'll type in the graphing calculator. So we'd hit y equals in the first spot. We'll do x to the fourth minus 18x squared plus 81. So this time we have x to the fourth minus 18x squared plus 81. X to the fourth minus 18x. This does squares. Let's see here.
Oh, I did it wrong.
You're good. So any questions on this here? Were we able to find the zeros? So what are the zeros? Well, we need to get the graph to find the zeros. X is equal to 3 and x is equal to -3 because that's where it crosses the x axis. And now there's an even number of zeros at these points because it actually works out that there are 2 at -3 and 2 at 3. There's 2 values at each. Any questions on these here? Has this made these a lot easier to solve? So here x is equal to 3 and x is equal to -3. And then we match up the correct graph. I think we're good with 3. Let's look at 4. Let's try using the graph with number 4. Because I skipped 2 because I feel like we're getting the hang of these here, yes? Because most of these here are just typing them in. So type number 4 into the graphing calculator. X cubed plus x squared minus 6x. X cubed plus x squared minus 6x. So we're going to type that into the graphing calculator. So to graph that, we're going to go over to y equals x cubed plus x squared minus 6x. And once we get that typed in, we're going to graph it. How many times does it cross? 3 times, yes? Because we have, it crosses once here, and once here. So we have 3 places where it crosses. Now, if it's kind of hard to see what those values are, we can go second graph to get a table. -3, 0, and 2. And again, where we're looking for the values to be 0 is in the y, because we're wanting to find out what value of x is going to make the function equal 0. Now, it worked out here that when x is 0, y is also 0. But we're mainly looking to see what values of x is going to make the y value 0. So we've got 3, -3, 0, and 2. So the solutions for this here are x is equal to -3, x is equal to 0, and x is equal to 2. We have these 3 here. Questions on these here? Okay. That's where we're going to stop today.